So the question is, set A. Two sets are there. One is A and the other one is B. Set A contains m elements. B contains n elements. I am not saying m is greater than n or n is greater than n. Then the first question, how many functions are there? How many different types of functions can be defined from A to B? Different time means how many total number of functions, how many into functions, how many onto functions, how many one onto functions, how many constant functions, like that. We do as much as possible. Okay? So first let us find total number of functions defined from set A to set B. Okay? Let us find total number of numbers. Total number of functions. Sorry. Function may be many to one. First, before I solve it, I just remind you those different types of functions. We have seen that function may be into or on. Function may be one or many one. So I am just drawing 4 diagrams here for your convenience to remember types of functions. One into function. This is one type. You should agree. I am giving one example. A1, A2, A3, A4, B1, B2, B3, B4, B5, or many more. This I am taking one into function. Okay? This is into function. Why? B3 has no image. This is one example. I want to take review example. Then let me write one example of one onto function. These are 4 types mainly. We have discussed into or onto. We have discussed many one or one. It may be many one into, many one onto, one onto, one into. Like that. One onto functions. Just write the example. Onto. No element unused. From codomain. Just giving the simplest example. This is an example of one onto function. Number 3. Many one into. This is many to one function, many to one into function. Into why? Because B3, B4 has no image. Then number 4, many one onto function. Do it with me. Many one onto function. Just show me in diagram. Many one onto. Okay? These are four types of functions. In our textbook, you will find these four types stated. Now, how many these type of functions will be there when number of elements here m, number of elements here n. All these types you have to write. Do you have to find it? Total number of functions, how many? Tell first. Yes, it is n to the power m. Why? Because one element can take any one of n. Second element can take any one of n. Third one, any one of n. How many times? M times. So this is n to the power m. Okay? Total number of functions done. Number of, we want to find number of into functions. First, how many into functions will be there? Okay, before the number of one function, let us find. How many one functions can be there? I did not say into onto anything, just I am saying one function. How many will be there? Tell. Huh? N to the power n minus n? No. One is mapping one only, not two. How many functions are there of that type? No. One is mapping one only. Here how many elements are there? M. Here how many are there? N. So for one function, n has to be greater than or equal to n. Here n greater than or equal to m. This should agree. N must be greater than or equal to m. So for one function, one is mapping one only. Say A1 has mapped B1, A2, B2. Wait. AM is mapping BM. Then apart from BM, how many more are there? N is greater than or equal to M. How many are remaining? N minus M number of elements. Agree or not? But who told you that A1 will go to B1 or A2, B2 and AN, BN? No, maybe B1, A1 going to BN, A2 going to B3. One is going 1, that's enough. So there is a step of selection. Selection is there. When you are going from set A to set B, you have to select how many elements? You have to select, well, how many elements? M elements out of N elements. Now, we select any one. Okay, no, wait. We select any M elements out of n elements from set B to make it 1 to 1. Here, to make it 1 to 1, we'll do this. Okay? To make it 1 to 1, we'll do this. Now, this m elements you have to select out of n. It can be done in how many ways? In CM ways. Okay. Now remaining how many elements are there? We have taken n greater than equal to m. Remaining n minus m elements are there. In how many ways it can be done? How many ways these n minus m elements can be selected? We are going to find number of 1 1 functions. Just 1 1 function. One is mapping 1 only. So out of these m elements, n elements, you have selected m in NCM way. Do you think that it's done? No. We have selected. Now we can arrange them also. Remaining n minus m, you think it. We don't have any problem with it. But these selected m elements can be arranged. So required number of functions will be LCM into factorial. LCM is what? Understand? So factorial m getting cancelled. This will be NPM. This particular topic is required for board and for your JEE. Very important. Number of 1 1 functions. Directly you will get this. This NPM. Okay? So what have we find? Number of 1 1 functions. What is found over there? Number of 1 1 functions. Let us do third part. Find number of bijection. Number of functions done. Let us find number of bijections. So, M now bijection means 1 on 1 2. This is possible when n equal to m. Therefore, number of bijections will be arrangement of these elements. Factorial n or factorial m, whatever you say. So number of 1 1 1 2 or number of bijections factorial n. Now number of onto functions. This will take long time if I start deriving it. I am not deriving it, I am just writing the formula. What? Here. This will be minus 1 to the power n minus r NCR r to the power m sigma r equal to 1 to n. This we can prove. I'll take another session to prove this. PIE, principle of inclusion and exclusion, will tell you how many onto functions are there. Number of into functions will be how many? This you can write now. Into the power m, total number of functions. You got into the power m. Formula I am writing equal to total number of functions minus total number of functions minus number of onto functions. Total number of functions we got into the power m. Okay. Now let us do it with, we set an example here. What example? Example 1. Let and b equal to PQRS. Find number of different types of functions from A to B. Understood? First, you note down this formula. Number of bijections factorial n has to be equal to m. Number of onto functions, this you never forget. Okay? Number of into functions. N to the power m minus r equal to 1 to n minus 1 to the power n minus r into NCR into r to the power m. Bijections not possible here. Here the formula for bijection n must be equal to m. But here n is factorial in formula. Under what condition? When n equal to m. But n equal to m in our problem, no. So bijection is 0, number of bijections. You just take total number of all other functions. Alright, sequentially. Number 1, answer. But first part. Total number of functions n to the power m or cube. Have I done correctly? It will be 4 cube. Number 2. Total number of bijections. Number of bijections equal to 0 as n not equal to m. Then number 3. Number of bijections 0. Then this one, number of 1 functions. How many? NPM. Is it possible? Yes. Because n is what? N is 4. M is 3. Number of 1 functions, 4 p. That is, oh, sorry, I'm wrong. 4p3 means factorial 4 by factorial 1, that is 24. Then number 4, number of onto function. Just try to write. So remember in a name always. It will be sigma r equal to 1 to n into r to the power m. This you write the summation first. Okay? N minus 1, r is 1 we are taking. N will put 4 definitely. Minus 1 to the power 2 to the power m to the power m n minus 4 nc4 4 to the power m. Is there or not? Now put in a name over there. Just put r up to 4 you can take, no? N is 4, that's why up to 4. Now put n equal to 4. So this will be minus 4c1 plus minus 1 to the power 2 is 2. M how many? 3. Then minus 3 cube plus 4 to the power 3. Because m is 3. So minus 4 plus 64. Okay? So answer is 64 plus 48. 112 minus 112. So number of onto functions going to be 0. Is it possible? Check once. Then number of into functions will be what? From total number of functions you will subtract. Okay? See you tomorrow again. Hello, Sanko.